So here we have 3 questions which ask you in all 3 cases to find an angle from information about the lengths of 2 of the sides. Let's have a look at question 1 and the problems it throws up. Okay, I've popped on the values that the blue length is 30 and the red length is 15. Now we start this question in a very similar way. We need to know which part of SOHCAHTOA to use. Well, from the angle's point of view, we clearly have an opposite and we have a hypotenuse. We're not interested in the adjacent, so the parts of SOHCAHTOA that contain an A can be eliminated. So we're left with a sine relationship. And I can write down that sine theta equals, SOA tells us what to do, 15, the opposite, divided by 30, the hypotenuse. And this is equal to 1 over 2. Might as well cancel that down to make it easy. So we're sort of stuck. We've got the sine, and we need to work backwards to the angle. And on this calculator, I have to push this button here called second. And it gives me a second layer. And if you notice, the sine, cosine, and tangent buttons have all changed to new buttons, which can be called sine to the minus 1. Now, just to add to the confusion, this function, as well as being known as sine to the minus 1, cos to the minus 1, or tan to the minus 1, rather confusingly is also known as arcsine, ARC sine, or asine. This calculator in its display uses asine, but don't get confused. This is just finding an angle from a side ratio. So let's use the calculator. We need to find sine to the minus 1, and you can see the display has come up as asine, of 1 divided by 2, close the bracket, and all we've got to do is push equals. So theta equals 30 degrees. Now that's one of the standard trig values that I asked you to remember, and I'll just write it out. But as you can see, we've worked backwards from the half using the calculator's sine to the minus 1 function, asine or arcsine, yes, I know, to get back to the angle of 30 degrees. Let's try another problem. Okay, let's start in the same way. We've got an opposite and we've got an adjacent. We're not interested in the hypotenuse, so SOH goes and CAH goes. And we're left with TOA. I can write that tan theta must equal the opposite, which is 8, over the adjacent, which is 12. Again, I might as well simplify that by taking a common factor of 4 away from the top and the bottom, and we end up with 2 over 3. We need to find tan to the minus 1 of 2 divided by 3. Hit equals, and it's come up with the answer of 33.6900, etc., etc. degrees. Okay, one more. Once again, we start off in exactly the same way. We are the angle, we look out. We have the hypotenuse, and we have the adjacent. Any part of SOHCAHTOA that contains the opposite is now discarded. So we're left with the cosine function. Once again, I can write that cos theta equals the adjacent divided by the hypotenuse, which is 20 over 30, which is 2 over 3. Cue the calculator. A cos 2 divided by 3 equals, and we get 48.189, etc., etc.